Okay, good afternoon. So, in the last class, we have completed the first part of the first unit. Okay, today we are going to discuss about the long base constructs and conventions. Okay, so I have referred most of the content from this textbook, that is designed through Verilog HDL by T.R. Padmanabhan and B. Bala Tripura Sundari. Okay, now we'll start the session. So long base constructs and conventions. Okay. So any software long base consists of these constructs and conventions. Okay. The constructs and conventions make up a software long base. So any source file in Verilog is made up of a number of ASCII characters. So what is ASCII? American Standard Code for Information Interchange. So any source file in Verilog is made up of a number of ASCII characters. Okay. The characters are grouped into sets which are called as lexical tokens. So in the last class we have discussed about these lexical tokens. Just English language like words. Okay. So whatever the characters which we are grouping into sets, that we can call as a lexical tokens. So what is the definition? A lexical token in Verilog can be a single character or a group of characters. Okay. It may be a single character or group of characters. So Verilog has 7 types of lexical tokens. How many? 7. Okay. So what are they? Operators, keywords, identifiers, white spaces, comments, numbers, and strings. All these also we have mentioned in the previous sessions. Okay. Now another thing. The Verilog is a case sensitive language like C. Okay. Like C language, Verilog is also a case sensitive. Okay. Next. Now let us see one by one. So the first one is keywords. Okay. How we define the keywords in Verilog? Let us see. So the keywords define the long base constructs. Okay. The keywords always define the long base constructs. Okay. So a keyword signifies an activity to be carried out, initiated or terminated. Okay. So what the keyword will make you to know? It signifies an activity which is to be carried out, initiated or terminated. Okay. All keywords in Verilog are in small letters. This you have to remember. All keywords in Verilog are in small letters. Okay. Now let us see what are the keywords available. So module, end module, begin, end, if, while. Okay. So what is module keyword signifies? It signifies the beginning of a module definition. Beginning of a module definition. Okay. Next, end module. So what it signifies? It signifies the end of a module definition. End of a module definition. These two we have already discussed in the last classes. Yes or no? Okay. Next, begin. What is begin? It signifies the beginning of a block of statements. So whenever we defined a module, inside the module we write some statements. Okay. That block of statements always starts with a keyword called begin. Okay. So it signifies the beginning of a block of statements. Next, end. It signifies the end of a block of statements. Okay. Next, if. It signifies a conditional activity to be checked. Okay. So if always signifies the conditional activity to be checked. Okay. So while, it signifies a conditional activity to be carried out. To be carried out. Okay. Let us, you will have a more clarity about this if and while. So whenever you deal with some programs in the Verilog. Okay. No. As far as now, it is enough to know what is the function of these keywords. Okay. So module is nothing but beginning of a module definition. End module is end of a module definition. Begin is beginning of block of statements. End is end of block of statements. If is conditional activity to be checked. While is conditional activity to be carried out. Okay. Next. Identifiers. Second one. Identifiers. So identifiers are nothing but the name tags. Name tags. Okay. Now let us see. Any program which requires blocks of statements, signals, etc. to be identified with an attached name tag. Okay. So any program requires blocks of statements, signals, etc. to be identified with an attached name tag. Such name tags are nothing but identifiers. Identifies. Okay. So we'll define some module. Inside the body of module, we'll define some statements. Okay. Now sometimes these statements are to be identified with some name tags. Okay. Such name tags are called identifiers. Identifiers. Okay. Next, it is very good practice for us to use identifiers. Okay. Closely related to the significance of a variable, signal, etc. Consent. Okay. This eases the understanding and debugging of any program. Okay. If you place the name tags meaningfully according to your statements, then it will be very easy to understand and debug of your any program. Okay. Next. So you please make a note of all these points. So first one, all characters of the alphabet or an underscore can be used as the first character. Okay. So whenever you are going to mention the name tag, what is the rule? All characters of the alphabet or an underscore can be used as the first character. Okay. So whenever you are mentioning the name tag, the first character can be characters of the alphabet, either it may be small letters or capital letters, and it should be a underscore. Okay. Next, what is the second thing? Subsequent characters can be of alphanumeric type or underscore or dollar sign. Okay. After the first letter, whatever the subsequent characters we are getting in the name tag, that can be of alphanumeric, that means both alphabets and numerics. Next, underscore or dollar sign. Okay. These two rules we have to follow when you are going to mention the name tag. Okay. Now let us see some examples. Okay, what is first one? NAME. Okay, so the first letter, it is started with character. Okay, all the subsequent characters are also characters, so it is valid. Okay, next, second one, underscore name. Okay, so it is started with underscore. Yes, it is mentioned in the rule, underscore. And next subsequent characters are alphabets. It is also valid. Okay. Next, third one, name, capital N, starts with capital N and subsequent letters are characters. Yes, it is also valid because all characters, that means either it may be a uppercase letters or lowercase letters, both are valid. That means the third one is also valid. Next, fourth one, capital N, name 1. Okay. So is it valid or not? Yes. The first letter starts with capital letter. The subsequent letters are alphanumeric. That means both alphabets and numerics. Here one is present. Yes. Here it satisfies this condition, alphanumeric. So it is also valid. Next, fifth one, name underscore dollar. Is it valid? So the first letter starts with alphabet N. The subsequent letters are alphabets and also underscore and also dollar. Yes, it is also correct. This one, underscore dollar, subsequent letters. So fifth one is also valid. Next, sixth one, name space AA. Is it valid? No, not at all. Even this one starts with a small letter n, but in the subsequent characters, there is a space. In the subsequent characters, there is a space. This is we have not mentioned here. That means the sixth one is invalid. Next, seventh one, dollar name. So the first letter starts with dollar, but the first letter must be a character of the alphabet, maybe small case or uppercase, or it can be underscore, but not a dollar. That means seventh is also invalid. Okay, next eighth one. The first letter starts with one and something. Okay, so but the first letter should not be numeric. It should not be a numeric. It should be either character or underscore, but it has started with numeric, therefore it is also invalid. Next, ninth one, at the rate name, some special character, it is also invalid. And a plus b, even it starts with letter a, but the subsequent character is the plus. Okay, it is not mentioned here. The subsequent letters can be alphanumeric, underscore, or dollar, but it should not be like this operator, plus operator. Therefore, it is invalid. That means out of these 10 examples, the first 5 are valid and 6 to 10, next 5 are invalid. Okay, did you understand? Next, this one. The same thing I have mentioned here. So the first 5 which are highlighted in the green, those are valid, but those which are highlighted in the red font, red color, those are invalid. Okay. Next, third one, white space characters. Okay, what are these white space characters? Generally, why we use these white space characters? In order to understand the program easily, for easy for readability. That means, uh, if I give you any sentence without any spaces and all these things, I will tell you to read that sentence. Then it is very difficult to read that sentence by you. Yes or no? Okay. So without spaces, without commas, without punctuation, just I will give you a running sentence. Okay, then it is very difficult to read that sentence. Okay, and that is why even in the Verilog language program, okay, inside the program sometimes you want to mention some comments. Okay, some comments, some statements like this. Okay, so in such a case, if you include these white space characters, then it is very easy to understand. It is very easy to understand. Okay, and it also improves the readability. It also improves the readability. That is the importance of this white space characters. Okay, so what are these things? So blanks, that is slash b, tabs, slash t, new lines, slash none, and form feed. Form feed means just a page breaking ASCII control character. Okay, page breaking ASCII control character. Form the white space characters in Verilog. Okay, so in order to include the white space, we have to use these things: slash b blank space, slash t tab space, slash n new line space, and form feed page breaking. Okay. Next, so in any design description, the white space characters are included to improve the readability. Just what I have said now. Okay, only to improve the readability. Next, they can be introduced. They are introduced between keywords or keyword and an identifier, between two identifiers, between identifiers and operator symbols, and so on. Okay, so where we have to include these white space characters, some examples have been given between these things and all these. Okay, next, white space characters have significance only when they appear inside the strings. Okay, that means whenever we observe a string, that is group of characters, in such a string only we can observe the significance of the white space characters. Yes or no? Okay, string is nothing but group of characters. Okay, in such a string we can know the what is the importance of these white space characters. Okay, next, fourth one, comments. So comments are generally used to describe your description. Okay, to describe your description in your own text. In your own text. So then what is the use of these comments? The comments are generally used to describe your description. But what is the use of these comments? That means anybody can understand. Okay, if somebody look into your program, if you include the comments beside every statement, then it will be easy for another person also to understand your program. Okay, okay, that is user understandability. Okay, that is the importance of comments. Okay, so so what they suggest is it is very good practice to comment a design description liberally. Okay, so comments. Okay, so giving comments in the Verilog language program is a good practice. Okay, is a good practice. That means a good practice to comment a design description liberally. Okay, so in comments we have single line comment, multi-line comments, two types. Okay, now let us see what is single line comment. So what is single line comment? A single line comment begins with this double slash and ends with a new line. Okay, so it always starts with a double slash like this and it always ends with a new line. Okay, now let us see some example, one example. So here some module declaration has been given, that is module d underscore ff, that is d flip flop, q, that is output, dp, that is data input, clk, that is clock input. Okay, now this is the module declaration. Okay, now if you include the comments, then it will be very easy to understand by anybody that these are the output, this is the output, this is the input, this is the input, like that. Okay, now you just observe here. So here the comment starts with double slash. Okay, now what is written here? This is the design description of a D flip-flop. Okay, next line, next line. Okay, it ends with a new line, remember. Next line, again double slash, it starts with double slash. Here Q is the output, very good. Next line, double slash, DP is the input, okay, and CLK is the clock. Then so if any program, if it consists of comments like this, then it is very easy to understand. Okay, even for you also, not for some other else, somebody else, not for somebody else. Okay, you write some thousands of program. If you write a thousands of program, at some point you may require to go back to your program and you have to refer some modules. In such a case, in order to have a quick in order to have a quick the quick view of your module, if you include these comments, then it will be very easy to understand your module. Okay, so that is the importance of comments. Next, let us see the multi-line comments. So what is this multi-line comment? So one can incorporate multi-line comments also without restoring to double slash at every line. Okay. So in case of single line comment, so for every line you have to include this double slash, yes or no? So in order to give this text, you have included this double slash symbol 3 times in every new line. Okay, in order to avoid that, we can use the multi-line comments. Multi-line comments. So for such multi-line comments, so what is the symbol we have to use? This is slash star. It signifies the beginning of a comment and star slash at its end. Okay, so all lines which are appearing between these two symbol combinations are together treated as a single block comment. Okay, so whatever the text you write between this symbol and this symbol, we call it as a multi-line comment. Now let us see the same example which we have discussed earlier for single line comment. Same I have taken module d underscore ff q dp clk. Okay, now how the multi-line comment has been written, just to see here. So it start with this one slash star, this one. Okay, now whatever the text you want to describe about this module, you just write here. So this module forms the design description of a D flip-flop, where in Q is the output of the flip-flop, DP is the data input, and CLK is the clock out input. Now end the comment with star slash, this one. Now finish. So but in case of single line comment, at every line you have to begin the comment with this one, this symbol double slash. But in case of multi-line comments, it is not necessary. Just once you mention at the start and you write your own text and just end with this thing. Okay, so this is multi-line comment. Next, you please make a note of this point. Multi-line comments cannot be nested. Okay, you should not nest up the multi-line comments. See this example. So first you begin the multi-line comment with this symbol. Okay, well and good. The following forms the design description of a D flip-flop. Again, you started this one, beginning of the comment symbol, which can be modified to form other types of flip-flops. You ended here. You terminated this one by here. Again, with clock and data inputs, you terminated here. Like this, you should not mention the multi-line comments. So once they started, so you write all your required text, then you end with this one, star followed by slash. Okay, but don't include multi-line comments in nested fashion, like this. Okay. Okay, next one, logic values. Fifth one, logic values. Now we'll see what are these logic values. Okay, generally, logic value means it just simply say that it is a logic 1 or logic 0. Logic 1 or logic 0. So logic 1 can also be recognized as a high level or true level. Yes or no? Logic 1, we can treat it as a high level or true level. Okay, whereas logic 0, we can call it as a either low level or false level. Okay, low level or false level, all these things are same. Okay, so not only this logic 1 and logic 0, not only this logic 1 and logic 0, two additional levels are also possible in the Verilog. What are they? X and Z. Remember, X and Z. So what is X? X always represents an unknown or an uninitialized value. Okay, this corresponds to the don't care case in logic circuits. So in switching theory and logic design subject, you have done the minimization of the Boolean expressions using Karnaugh maps. 4 variable Karnaugh map, 5 variable Karnaugh map, 3 variable, 2 variable, like that. Okay, in order to minimize your Boolean expressions. In such a case, in some cases you have used the don't care symbol, yes or no, like this. Like this, you have used this don't care symbol in the Karnaugh maps. Why? In order to minimize the Boolean expression further. Okay, so that X can also be represented in the Verilog long ways. So what it represents? It represents an unknown or an uninitialized value. Okay, no value is initialized to X. Okay, so don't care means, so how we can take the value for X? In some cases we can take the value X as a 1. In some cases we can take the value X as a 0. Yes or no? That flexibility. Okay, next one, Z. So what is Z? Z represents always a high impedance state. High impedance state. ఇది ఎప్పుడు వస్తుందమ్మా? This is possible when a signal line is tri-stated or left floating. When a signal line is tri-stated or left floating. Okay, that means, so whenever you connect two circuits with a net or a wire, okay, due to some reasons, if the wire has been broken up, okay, then what happens? That wire will be in the floating state. Now what is the signal value on that wire? So it will be neither 1 neither 0. Okay, it will not give you either 1 or 0. So then what is that state? It is called, what is that state? It is called the high impedance state. It is called the high impedance state. Okay, so now these two values are also comes into the logic values. Okay, now what are the logic values we are using in the Verilog language program? Okay, 4 values, that is logic 1, logic 0, X and Z. X and Z. Okay, next we'll see the data types. So what are the data types? Next one. So in Verilog, we have two types of data types, that is net data type and variable data type. How many? Two data types. So first one net data type, second one variable data type. Okay, So here one thing you have to remember, that the data type of each variable or signal has to be declared prior to its use. Prior to its use. Okay, before using that, you have to declare what data type it is. What data type it is. Okay. Next. Now we'll see the net data type. What is the first one? Net data type. Now we'll see what is this net data type. Okay, already in the previous classes we have discussed about this net. Yes or no? Net delay or wire delay. The same thing. Okay, net. So what a net signifies? A net signifies a connection from one circuit into another, from one circuit unit to another. This is what we have discussed in the last sessions. Yes or no? Okay. I think you remembered that example or not. Two NOT gates, two inverters are connected by means of a wire or by means of a net. Okay. The same thing here again it is defined. A net signifies a connection from one circuit in unit to another. Okay. So such a net carries the value of the signal it is connected to and transmits to the circuit blocks connected to it. Okay, definitely. So whenever two logic gates or whenever two circuits are connected by means of a net or wire, definitely that net or wire can carry some signal value. Yes or no? So the output of first NOT gate is connected to the input of second NOT gate by using net and wire. Then what is the signal value on that net or wire? It depends upon the output of the first NOT gate. So whatever the output we are getting at the output of the first NOT gate, that output will travel. It will travel on the net or wire which is connected to the next second NOT gate. Okay, that is this one. So such a net carries the value of the signal it is connected to and transmits to the circuit blocks connected to it. Okay. Next, if the driving end of a net is left floating, the net goes to the high impedance state. That is obviously. Okay. So if anything is left floating, then it enters into the high impedance state. If it is normal, if it is in normal case, that means one NOT gate is connected to second NOT gate by using net or wire. Okay. If there is no problem, then that net or wire always will carry some signal value. It may be either logic 1 or logic 0. But if something happens, if the net is entered into the floating state, then definitely we call it as a high impedance state. High impedance state. Okay. Now let us see. A net can be specified in different ways. Okay. How? Wire and try. Wire and try. We can also call the net as a wire. Yes or no? The net can also be called as wire. Okay. Now another way of specification is try. Okay. So what is wire? Let us say it represents a simple wire doing an interconnection. That is what we have discussed. Okay. Only one output is connected to a wire and is driven by that. Okay. So what is wire? Just it represents a simple wire doing an interconnection. Yes. Two NOT gates are connected by using a net or wire. Yes. Only one output is connected to a wire and is driven by that. Okay. This you remember. Only one output is connected. Okay. Next, coming to try. So it represents a simple signal line as a wire. Unlike the wire, a try can be driven by more than one signal outputs. This is the difference. Okay. A try can be driven by more than one signal outputs. Okay. Try is also nothing but a simple signal line as a wire only. But what is the difference between wire and try? In wire, only one output is connected. But in case of try, it can be driven by more than one signal outputs. It can be driven by more than one signal outputs. That is the basic difference between wire and try. Okay. Next. So wire nets may be used if a net has only one driver. If a net has more than one driver, then trinet may be used instead. I think you got more clarity by this statement. Okay. Once again, wire nets may be used if a net has only one driver. If a net has more than one driver, then trinet may be used instead. Okay, this is about the net data type. Okay, now what is the second one? Variable data type. Now tell me, in net data type, so what are the two things we observed? Wire and try. Okay, next one, variable data type. Now let us discuss what is this variable data type. Okay, so what is this variable? Okay, now let us see. A variable is an abstraction for a storage device. Yes, a variable is nothing but an abstraction for a storage device. Okay, so how we can declare the variable? It can be declared through the keyword reg, R-E-G. Okay, and stores the value of logic level 0, 1, either X or Z. Okay, so what is variable? Just an abstraction for a storage device. So how it can be declared? How a variable can be declared? Through the keyword reg, R-E-G. Okay, and what it stores? It stores the all the logic, four logic levels, that is 0, 1, X or Z. Okay, next, a net or wire connected to a reg takes on the value stored in the reg and can be used as an input to other circuit elements. Is it clear? So if you connect any net or if you connect any wire to the reg, then what that net or wire will take? Just they will take whatever the value which is stored in the reg. Okay, once again, if you connect a net or wire to a reg, to a REG, okay, then whatever the REG contains, that value will be taken to the net or wire. Okay, now once again read this. A net or wire connected to a reg takes on the value stored in the reg and can be used as input to other circuit elements. Okay, that means whatever the value that is stored in the reg, that can be taken by net or wire and they can pass to other circuit elements. Okay, next, here one thing you have to remember, that but the output of a circuit cannot be connected to a reg. Okay, so that means whatever the value that is stored in the reg, it can be taken by the net or wire in order to pass that value to the other circuits. But the output of a circuit cannot be connected to a reg. The output of a circuit cannot be connected to a reg. Okay, so whatever the value that is stored in reg is changed through a fresh assignment in the program. Okay, so this thing you remember. The output of a circuit cannot be connected to a reg. Okay, now you just see these four statements once. If you have any doubts, you can tell me. Okay, next, what are the other variable data types? Time, integer, real and real time. Okay, are the other variable data types of data. Okay, so this is about the variable data type. Okay, so in the next class we'll discuss about this operators. Okay, so what we have discussed in the today's class. So what are long-based constructs and conventions? What are lexical tokens in English like keywords, English like words? Okay. So what is a lexical token? Single character or a group of characters? How many lexical tokens we have in the Verilog? 7 lexical tokens. Is Verilog a case sensitive? Yes, Verilog is a case sensitive. Okay. So in this we have discussed about some of the long-based constructs and conventions. So what is the first one? Keywords. Okay, and second one, identifiers, nothing but name tags. Okay, next, third one, whitespace characters. Okay, and fourth one, comments. Okay, and fifth one, logic values, and sixth one, data types. Okay, totally we have discussed the 6 language constructs and conventions in today's class. In the next class we'll discuss the remaining constructs and conventions. Okay, thank you. Have a nice day.